Okay, so let's go back to where we started. The first equation we had was our spring equation. We said the force is proportional to the deflection plus that we had an offset, because in a real spring we're going to have an offset and we're going to have a spring constant. The second equation we had was that delta x, our deflection, is proportional to arc length, which was a pi minus theta, and a radius r, plus we had some type of offset, 0.34 inches, and that was telling us that we had to pull the spring to install it into the camera so that we had an actual holding force in the system. Now let's think about SI units. Let's keep SI units in general because it's going to make everything much better. So we're going to have the force is going to be in newtons, the K is going to be in newtons per meter, my deflection is going to be in meters, and my offset, B, is in newtons. That's how much the spring had a little bit of force just to get it started. And then if I look at my other equation, I have delta x, which is going to be in meters. I have that radius, which is going to be in meters. I'll have a pi minus theta. That has to be in radians, so it's unitless. And then lastly, I'm going to have the 0.34 inches, which was that you had to extend the spring to install it in the camera. So 0.34 inches, you have to multiply by 2.54 centimeters for every 1 inch. And 1 meter is 100 centimeters. So we're putting everything into SI units. So now we're going to have a delta x equals r pi minus theta plus, I did a quick calculation of 8.636 times 10 to the minus third, and then that should be in meters. So now we're going to just do some algebra here. We have F equals K delta x plus B. We're going to just substitute in for delta x. That's all we're going to do. So F equals K times R pi minus theta plus K times 8.636 times 10 to the minus third. So it's K times delta x, and I still have to add in that B. Don't forget that. So now if I look at my equation, I have F equals minus KR theta, that's that one, plus KR pi, that's that one, plus K 8.636 times 10 to the minus third, plus B. So if you look at this equation, this is not hard. This is just saying F is proportional to theta, so I have a minus kr theta, F is proportional to theta, plus some giant offset, I don't know, you can call it a big C, and this is the offset. So again, we just look like we have a linear equation, y equals an mx plus b, right? Where if you had y equals mx plus b, this is that. Theta is the x, and the slope is minus kr, and that F is your force. Always remember that theta needs to be in radians.